Welcome to this explainer. Right now, we're standing at this really incredible intersection where traditional, heavy-duty hardware meets the absolute future of intelligence. Today, we're breaking down the DEVI automation solution syllabus to explore the modern edge of industrial engineering. We're talking Python for AI, PLC programming, and custom software development. Whether you're an electrical engineer, an IoT developer, or just an engineering student trying to figure out your next move, this walkthrough is going to show you exactly how to bridge that gap between the factory floor and cloud-based AI.
But first, we really have to address the elephant in the room. Why should a traditional automation engineer even bother learning Python? Look, we all know programmable logic controllers, PLCs, are the absolute bedrock of industrial automation. They're incredibly reliable, and frankly, they aren't going anywhere. But as industries evolve, we desperately need to figure out what comes next. How do we handle massive amounts of data, predictive analytics, and all those complex cloud integrations that traditional ladder logic just wasn't really built for?
So here's our roadmap for today. First, we'll look at why Python rules automation. Second, extending PLC capabilities. Third, AI, IoT, and smart agriculture. Fourth, architecture and libraries. And finally, your career and roadmap.
All right, let's dive right into Section 1, Why Python Rules Automation.
There's a very good reason Python is dominating right now, and it's highly practical. For starters, it has an incredibly easy syntax, which is a lifesaver if you're coming from a purely hardware background. Plus, it's completely free and open source. That means no massive corporate licensing fees, right? And it's backed by this huge global community. But honestly, the real game changer for us is its unrivaled AI support and those powerful, ready-to-use libraries that are built specifically for heavy-duty industrial applications.
Moving right along to Section 2, Extending PLC Capabilities.
Okay, let me make something absolutely crystal clear here. Python does not replace PLC programming. I'll say that one more time, just so we're on the same page. Python is not here to replace your PLCs. The PLC is designed for reliable, isolated, real-time factory control, and it is fantastic at that. Instead, think of Python as the ultimate bridge. It expands the PLC's capabilities by layering on data logging, AI, and cloud integration. So you get to keep the rock-solid reliability of the hardware, but you're adding the massive processing brains of modern software.
So how exactly does it pull this off? Well, Python basically speaks the language of the factory floor. It can seamlessly read and write PLC data using standard industrial protocols. We're talking Modbus TCP, OPC UA, Ethernet/IP, MQTT, the whole shebang. It opens up advanced data logging, real-time alarm monitoring, and automated production reports. And the coolest part, it works right out of the box with the major brands you're probably already using. Siemens, Allen Bradley, Mitsubishi, Delta, Omron, Schneider Electric. It connects with all of them.
Next up, Section 3, AI, IIoT, and smart agriculture.
This is where things get seriously cool. Python is the key that truly unlocks artificial intelligence for the industrial sector. With it, factories can deploy deep learning and computer vision to do high-speed visual defect detection right on a moving conveyor belt. It makes predictive maintenance a reality, meaning your system can literally tell you a motor is going to fail before it actually breaks down. We are even seeing generative AI chatbots being trained on massive 500-page machine manuals, so instead of an operator digging through some dusty binder to troubleshoot a problem, they just ask the AI in real time. How wild is that?
Let's actually trace the path of a single data point to see this industrial IoT flow in action. It starts down at a simple, low-cost ESP32 microcontroller. That data gets transmitted via the MQTT protocol, where Python catches it for processing. Python then tucks it away in a database, pushes it up to an industrial dashboard for your floor operators to monitor, and finally sends a mobile notification directly to a manager's phone if something falls out of spec. It's just a brilliant, completely seamless pipeline.
And hey, that exact same logic applies outside the factory walls too, specifically in smart agriculture. Picture this. A soil moisture sensor feeds data to an ESP32, which shoots it over to Python. But here's the magic trick. Python uses AI decision logic to independently analyze that soil data. If it decides the crop is too dry, Python automatically triggers the water pump itself and instantly pings the farmer with a notification. It's intelligent, self-contained automation at its best.
Which brings us to Section 4, Architecture and Libraries.
The real secret sauce of Python's power? It's the libraries. Down at the hardware level, you've got Snap 7 for Siemens PLCs and PyModbus. Moving up a layer to intelligence,
OpenCV handles your computer vision, while TensorFlow and PyTorch do the heavy lifting for deep learning. If you're doing intense data analytics or logging, Pandas and NumPy are your best friends. And for the cloud and processing side, you've got FastAPI, Flask, Paho MQTT, and SQL Alchemy. No matter what your industrial use case is, Python literally has a highly optimized tool ready to deploy.
When you snap all those library puzzle pieces together, you get this complete industrial architecture. This right here is the total journey of your data. Starting at the hardware level of the PLC, processed by a Python script, structured into a database, visualized on a local dashboard, pushed up into advanced AI and cloud integrations, and ending right at the end-user mobile app. And guess what? Every single step of that massive chain is facilitated by Python.
But wait, because Python is a full-fledged programming language, its utility doesn't just stop at the machines. It is incredibly powerful for developing the custom software that runs the entire business side of the operation. We're talking company websites, customer portals, inventory management, full-blown ERP and CRM systems, and billing software. It's the ultimate tool for unifying the grit of the factory floor with the strategy of the corporate office.
Finally, let's hit Section 5, your career and roadmap.
So how do you actually build these skills? This timeline right here gives you a clear, actionable 6-month game plan. Month 1, you tackle Python basics and object-oriented programming. Month 2 is all about handling files, APIs, and databases. By month 3, you are working with MQTT and actually talking to PLCs. Month 4 is where you fold in OpenCV and AI. Month 5 covers cloud connectivity, and by the time you hit month 6, you are building full-scale, end-to-end industrial automation projects.
And why should you put in those 6 months? Simply put, the industry demand for these hybrid software-hardware skills is off the charts right now. When you combine your traditional engineering chops with Python, you're opening doors to roles like AI engineer, industrial IoT engineer, robotics engineer, or data engineer. The growth trajectory and the salary expectations for professionals who can actually bridge the gap between PLCs and AI, they are phenomenal. By the way, the syllabus and the roadmap we just explored today come directly from DEVI Automation Solutions. Their whole philosophy is smart technology, powerful solutions, better tomorrow. They offer some really comprehensive services, covering everything from traditional PLC programming and SCADA systems, all the way up to AI solutions, industrial IoT, smart ag, and custom software development. If you found this explainer helpful, definitely make sure to like, share, and subscribe to DEVI Automation Solutions for more brilliant tutorials on smart tech and industrial automation.
So I want to leave you with this final thought. The tools you need to completely revolutionize the factory floor, to make agriculture incredibly smart, and to connect the physical world to artificial intelligence, they're completely free and they're just waiting for you to use them. So the only question left is, are you ready to build the future of automation with Python? Thanks so much for joining me for this explainer, and I really encourage you to start your Python journey today.